Hi guys, this is Mrs. Foy, and this is a screencast about the history of the atomic theory. So, there's a lot of misunderstanding about what a scientific theory is. And a scientific theory is not just something that is a hypothesis or something that is a guess. It's actually backed by a lot of data. And when that evidence changes over time, then then a theory has to adapt to the data. And that's exactly what has happened with our understanding of what an atom is. So you might want to take some notes on this. We're going to be talking about this more in class, but these are important concepts. So the word atomos means not to be cut. So let's talk a little bit about that. So over the years, our idea of what an atom has changed over the years. But the very first person who came up with this idea of an atom was in the year 400 BC. And this person had no way of experimenting about this. This was just an idea. But over the years, it has changed over time. And these are some of the scientists. After the end of this lecture, you should know who these scientists are and what their contribution to the theory of the atom was and how it has changed. So the very first philosopher who came up with the idea of an atom was a guy named Democritus in 400 BC. He did not do any experimentation, but he basically came up with this idea that could you take stuff and make it into smaller and smaller pieces, or was there a limit to how small a piece is? And so he basically came up with this idea of an atom. And an atom was the smallest piece of some stuff that was still that stuff. And he said that this was called atomos, which is the Greek word for not to be cut. And so in his mind, atoms were small, hard particles that were made of the same material, but were different shapes and sizes. And they were infinite in numbers, and they were always moving around and capable of joining together. And we can see now that some of his ideas were kind of correct, and some of them were not correct at all. But his theory was basically ignored for 2,000 years because at the time there were some more popular philosophers named Aristotle and his student Plato, who had a more respected theory that was wrong, but that was held on to for a long, long time. And Aristotle and Plato favored this earth, fire, wind, and water kind of thing as approach to nature, and we know that is not true. So this is basically a timeline of the atomic theory. So here we have Democritus, and we see about 2,000 years before some big changes started to happen in the atomic theory. So in the early 1800s, there was an English chemist named John Dalton who was the first one to really perform experiments that led to the acceptance of the idea of an atom. So his idea was that all the elements are composed of atoms, and his idea of an atom was that they were indivisible, indestructible particles, which they're not. But that was his idea. And he said that atoms of the same element were all exactly alike, which is a little bit true and a little bit not true. And atoms of different elements are different, and that you could take atoms and join them together to make compounds. And this theory became one of the foundations of modern chemistry, and he backed this up with some experimentation. Well then, in the late 1800s, there was a scientist named J.J. Thomson who gave the first evidence that an atom was not a billiard ball, but that it was made of even smaller particles. And what he did was he studied the passage of an electrical current through a gas. And he could hold magnets up to this passing of a current, and he could actually bend that ray that was going through, and he deduced that this was a stream of negative particles that we call electrons. And so he wondered where these negative charges came from. And so what he deduced from his experiments is that they actually came from inside the atom. And so this was like a shocker to everybody, that an atom had smaller pieces. And he originally called these negatively charged things corpuscles. We know them today as electrons. And he looked and looked for them. He found these electrons, which he knew were in this flow of electricity. And so he thought that there had to be a positively charged particle in the atom someplace, because he knew that atoms were neutral, but he could never find those positively charged atoms. So what his theory was of the atom is that we call it the Plum pudding model. So he imagined this atom as kind of like a plum pudding that was made of positive charges, and that the electrons were these negative particles, like kind of raisins in this pudding. So plum pudding was a dessert that people liked in England, still today. And so he imagined an atom kind of like the plum pudding with the raisins as the electrons. And so that was how his idea of the atom looked. So then, a few years later, a very famous experiment was done by a scientist named Ernest Rutherford. And this was in 1908. And so what Dr. Rutherford did is he took a little gun that was shooting positively charged particles at a very thin sheet of gold foil. And this gold foil was so thin that it was only about 2,000 atoms thick. And so the idea is he had this little particle gun that he was shooting. His graduate students actually were shooting these little particles called alpha particles at this gold leaf. And so he believed that they would just go straight through, but some of them, interestingly, ended up bouncing back. So here's a diagram of what this experiment was. So he had this little source of radioactivity, and these were alpha particles. We know these were positive charges, that he was shooting through this screen to get to this gold foil. And what he thought would happen is he thought that they would just pass straight through, and he had these little fluorescent screens around that would light up when one of the alpha particles hit it. And to his surprise, some of the particles bounced straight back. So here is a real quick little video of a cartoon of what this actually looked like. This is a very famous Rutherford's gold foil experiment. So what he was doing is he was shooting these alpha particles at a detector, and through a piece of, he was shooting it out of a source, and he was shooting it through the gold foil, and he had this detector material that would light up when the alpha particles would hit it. And what he is expected is that they would go straight through this very thin layer of gold atoms. But what actually happened is that some of them, a very few of them, bounced back, and some of them bounced straight back. And so what his famous quote is that he couldn't have been more surprised had you shot a gun at a piece of tissue paper and it bounced back at you. So as he is watching these alpha particles hit this gold foil, you see that most of them go straight through, some of them go off at an angle, and some of them every once in a while bounce straight back. And so what he took from this evidence is that there is a very small positively charged center that was repelling his positively charged bullets, these alpha particles. And so he called the center of the atom, this small positively charged center, the nucleus. But because most of his alpha particle bullets went straight through the gold, he reasoned that the nucleus must be very, very tiny compared to the atom as a whole. And so Rutherford's idea of an atom, so this is now changing the atomic theory again, is that there is a very small positively charged nucleus with negatively charged particles scattered around outside around the edge of the atom. And so that changed the theory of the atom just a little bit more. And then a few years later, there was another scientist named Bohr, Niels Bohr, who proposed an improvement on Rutherford's model. And what he said is that these electrons are at specific energy levels around the positively charged nucleus. And by the way, these scientists calculated that the nucleus was so small compared to the size of the atom, which was mostly empty space with electrons buzzing around, that it would kind of be like the nucleus being the size of a grapefruit if the whole atom was the size of the Empire State Building. So if the nucleus was a grapefruit, the whole atom's size, the whole atom's diameter would be the size of the Empire State Building. So an atom is mostly empty space, right? But Bohr's idea is that these electrons went around in very specific energy levels, kind of like an orbit, kind of like planets orbiting the sun. And this is called the Bohr Model. And some of what the Bohr Model says we know to be correct today, but some of it is not correct. And so this atomic model probably looks familiar to you, where you have this idea of a small nucleus, and then you have these electrons buzzing around like an orbit. And we know from the advancement of our atomic model that this is partially correct. We do know that an atom is mostly empty space. There is a very small positively charged nucleus with electrons on the outside, but electrons do not just go around the nucleus like cars on a track. And that leads us to what we call the wave model of the atom. And this has been developed using some really crazy mathematics called quantum mechanical theory. And so what the wave model tells us is that electrons don't just travel around in a track, not like in a definite path like planets around the sun. They actually are traveling in waves, and that it is impossible to say exactly where any electron is. We can only say in this electron cloud the probability of where that electron is based on how much energy that electron has. And the small positively charged nucleus is in the center, but these electrons in these clouds make up most of the space of the atom. And they are actually in specific energy levels, and you can only calculate the probability of where any one electron is. You can't say for sure. But what we do know about electrons is that electrons with the lowest energy are found closest to the nucleus, and electrons with the highest energy are found in the outermost energy levels furthest away from the nucleus. So electrons that are closest to the nucleus are going to have the lowest energy, and electrons that have the most energy are farthest away. And so comparing these 1, 2, 3, 4, 5, 6 theories of the atom in order from the most primitive to the most advanced, you can kind of see where some of these characteristics come into place. And so I hope this has been helpful, and now you know a little bit about the theory of the atom and how it has changed over time. And hopefully you can compare the different scientists with their contribution to the theory of the atom. See you in class.